In this video, we're going to be looking at finding gradients of perpendicular lines. Before we carry on with the video, make sure you're comfortable with the idea of reciprocals. Pause the video and find the reciprocals of these four numbers. Here's what you should have got. The reciprocal of 3 is simply 1 over 3. The reciprocal of 1/3 is 1 over 1/3, which is 3. The reciprocal of 7/5 is 1 over 7/5, which is 5/7. And the reciprocal of -3/8 is -8/3. If you're unsure about this, you need to go back to topic N3A to learn about reciprocals. I won't go into too much more detail in this video, but basically the reciprocal of a number n is simply 1 over n. So finding the reciprocal of a whole number, like 3, is easy. The reciprocal is just going to be 1 over 3. Now for fractions, finding reciprocals is a little bit more complicated, and like I said, I'm not going to go into details in this video, but essentially, to find the reciprocal of a fraction, you just flip it over. What I mean by that is that you make the denominator the numerator and the numerator the denominator. So you can imagine really there is a hidden 1 there. 3 is the same as 3 over 1. And in fact, the same thing applied in the case of this whole number. You can think of 3 as 3 over 1, and to find the reciprocal, all we did was swap the numerator and denominator around. Same kind of things going on here, and even here. -3/8, the reciprocal of that is simply -8/3. In this video, we're going to be looking at gradients of perpendicular lines. Now, in the previous video, we saw that two parallel lines would have the same gradient. When you've got two perpendicular lines, their gradients will multiply together to give you -1, unless one of those lines has got a 0 gradient, but we'll look at that a little bit later. So, another way of saying what I just said is this. If one line has a non-zero gradient m, then any line perpendicular to that first line will have gradient -1 over m. And that's what I said before. I said if you multiply the two gradients together, you'd get -1. And m times -1 over m gives you -1. Let's have a visual illustration of what I mean. Here we can see I've got a straight line with a gradient of 2. For every one step across we need to go 2 steps up to get back onto the line. Now here is a perpendicular line. Remember, perpendicular means at right angles. So this line is at right angles to the first one, and this has gradient -1 over 2. In other words, -1/2. Every one step across we need to go half a step down. Or another way of thinking of it is that we've got a change in y that's -1 because we're going down 1, divided by a change in x of 2. Notice how this fits the definition that we've just spoken about. If this line has gradient 2, then the perpendicular line will have gradient -1 over 2. Another way of thinking of it is that the two gradients should multiply to give us -1. So -1/2 times 2, does that give us -1? Yes, it does. So these two lines really are perpendicular. And in fact, we've now got our answer to the first question. The gradient of the line y equals 2x minus 1 is 2. So the gradient of the perpendicular line is going to be -1 over 2, or -1/2. Now, if you remember back to the start of the video, I got you practicing some reciprocals. And that's because I like to think of perpendicular gradients as being the negative reciprocals of each other. Remember, the reciprocal of m is 1 over m. So -1 over m is just the negative reciprocal of m. And remember, we can find a reciprocal simply by flipping it over, swapping the numerator and denominator around. And to find the negative of a value, all we need to do is change its sign. So we can use that to very quickly do the next question. In the second question, we've got y equals -3/2x plus 5. In this case, the line has gradient -3/2. A line that's perpendicular to this is going to have a gradient that is the negative reciprocal of -3/2. So because we were looking for a negative reciprocal, we're going to need to change the sign. So we're going to end up with a positive value. And remember reciprocal, so we need to swap these around. So the gradient of a perpendicular line is going to be 2/3. We can check this makes sense. Remember, the two gradients of these two perpendicular lines need to multiply to give us -1. Let's just test that out up here. If I've got -3/2 and I multiply it by 2/3, what do I get? Well, I can multiply numerators. So -3 times 2 is -6, and 2 times 3 is 6, and -6/6 is indeed -1. So I do have perpendicular gradients here. We have to take more care with this one. This time the equation is not in gradient intercept form. However, we can rewrite it. So 3x plus 2y equals 6 can be rewritten as 2y equals 6 minus 3x. So I've simply subtracted 3x off the left and the right hand sides. And now I can divide the left and the right hand sides by 2, and that will give me y equals 3 minus 3/2x. And this time I've got a gradient again of -3/2. So the perpendicular line, or any perpendicular line to this one, is going to have a gradient that is the negative reciprocal of -3/2, and as we've already seen, that is 2/3. So that's our answer. Here are equations of 3 more straight lines. Pause the video and find the gradient of a perpendicular line to each one of these. Here's what you should have got. For this first one, we've got a line that has a gradient of -5. That means any perpendicular line to this one is going to have a gradient of -1 over -5. Remember, we're looking for the negative reciprocal. And -1 over -5 actually simplifies to positive 1/5. You can think of this as multiplying the numerator by -1 and the denominator by -1 to get an equivalent fraction. For this one here, we've got y equals 1/2x plus 7. The gradient this time is a half. So a perpendicular line is going to have a gradient of -1 over 1/2, which remember is the negative reciprocal of 1/2. Well, the reciprocal of 1/2 is 2, just swapping those around. And because we're looking for the negative reciprocal, we want the gradient to be -2. Any perpendicular line to this one will have a gradient of -2. Finally, we've got this line with the equation 5x minus 3y plus 7 equals 0. What I'm going to do is rearrange this into gradient intercept form. I'm going to add 3y to the left and the right hand sides, and that's going to give me 3y on the right, and that equals 5x plus 7. And then what I'm going to do is divide both sides by 3. So I'm going to have y on the right hand side, and on the left hand side I'm going to have 5/3 x plus 7/3. Now all I really care about here is the gradient, so that's 5/3. That means any line perpendicular to this one is going to have a gradient that is the negative reciprocal of 5/3. So the reciprocal of 5/3, that's 3/5, and we're looking for the negative reciprocal, so that's -3/5. I recommend you scroll down the page and play around with the applet we've got. You can move a couple of points around to set the gradient of one line, and the applet will show you the gradient of the perpendicular line. Before we finish this video, I just want to raise one point that I mentioned earlier on. If we look back at this definition, you'll notice that I said if a line has non-zero gradient m, then the gradient of a perpendicular line will have gradient -1 over m, this negative reciprocal. Why doesn't this work when you have gradient 0? Well, the problem is if you have a line with 0 gradient, then it would seem like the perpendicular line should have gradient -1 over 0. And that's not really defined. Some people might call it infinity, but let's see what that looks like in a diagram. Here you can see we've got a line with gradient 0. It's a horizontal line. A perpendicular line, therefore, will be vertical, and you can see a perpendicular line here. Now, what is the gradient of this vertical line? Well, it's just not defined. Remember, a gradient really tells you how many squares up you need to go for every one square across you go. So on this horizontal line, every time we go one square across, we go 0 squares up. That's why this has a gradient of 0. On this line, every time you go one square across, it doesn't matter how many squares up you go, you're never going to get back onto your original line. So this is a special case you have to keep in mind. If you've got a horizontal line, then the perpendicular line to that will be vertical and vice versa. But in these cases, you can't use the idea of the gradient of one line being the negative reciprocal of the gradient of the other. Like I've said, this is a special situation where that doesn't apply.